So what I'm going to talk about today is where we're at with Java, because JDK 9 was released in September last year, and we had been waiting quite a long time for that. And the other thing I have to say before I start really is that obviously I work for Azul Systems now. Used to work for Oracle, used to work for Sun, now work for Azul Systems. And it's actually very special for me to be here in Novosibirsk because we have an office here. So this is really good for me. So I think there's some of my colleagues here. So put your hand up if you work for Azul. Oh, good. Okay, so we've got several of the people from the Azul office here. We only have 4 offices in the world. 2 of them are in Russia. So we have one in Novosibirsk, we have one in St. Petersburg, and then we have one in Bangalore, and our head office, which is in the US. So like I said, it's very special to be here today. What we're going to talk about is where Java is at. Because, as I say, JDK 9 was released in September of last year. We waited a long time for that. And really the reason that we waited so long was because of the substantial change that happened in JDK 9, which is modularity. So we'll talk a bit about that. We'll talk about what the impact of modularity is on developers, what the impact is on how you use Java to deploy your applications. But then what I really want to do is I want to focus on what's going to happen next. Because, again, when JDK 9 was launched last year, there were a number of other changes that Oracle announced about how they wanted to develop Java in the future, specifically the OpenJDK project. So we'll talk about the fact that there's going to be a new cadence of releases, this new speed of release. And then we'll also talk about what are the new features that are coming in Java, both the language, the platform, the JVM, and so on. Because it's interesting because Java is 23 years old this year. So it's a very mature platform from the point of view of developing software. And yet there are still lots of ideas for how to improve Java. So we'll talk about those as we go through. So JDK 9. As I said, the big change in JDK 9 is modularity. And I borrowed this slide from Oracle. It's a public slide, so I haven't stolen it, I've borrowed it. And what it shows is that there are lots of new features in JDK 9. Most of them, I will admit, are fairly small. And I've done a presentation a number of times called 55 new features in JDK 9. And it's actually not too difficult to find that many features. So lots of small things, lots of slightly bigger things, and one really big thing. The big thing is the Java platform module system, or as the project was called, Jigsaw. Now what this has done is it's taken the big set of class libraries that we've had, which makes Java very powerful, and it's broken it up into a number of smaller chunks. Now if you go right back to the very beginning of Java, JDK 1.0, so let's have a quick show of hands. Anybody here used JDK 1.0? Okay, one person at the back, a couple of people, right? Yes. So there are a few people who can remember that far back. Well, yes, I'm one of the people who can remember that far back because I actually joined Sun Microsystems at about the time JDK 1.0 came out. And I remember that when I was learning to use Java, I looked at the class libraries, and there were about 200 class libraries in what was rt.jar. And I thought to myself, 200 class libraries, yeah, I can remember those, I can hold them all in my head. And then over time, we've gradually added more and more libraries to rt.jar. If you look at JDK 8, you'll find there's about 4,500 classes in rt.jar. Now this is really good because now we don't have to write a semaphore class. We don't have to write a linked list class. We don't have to write any of the collections or the SQL statements or anything like that. All of those are there for us. It's one of the things that makes Java really powerful. But the problem is that nobody needs all 4,500 of those classes in any one application. So we've got this very, very big collection, and we really needed to simplify it so that you could select only the bits of the class libraries that you needed for a specific application. So that's what modularity is all about. Take all those classes and break them up into more manageable units. So now, if you look at the JDK, what you've got is 97 modules. And of those, there are 28 that make up Java SE. That's the standard that's defined by the JCP through the relevant Java specification request. There's also a group of other ones which sort of make up the JDK itself. So there's JavaFX. If you're doing any of these sort of desktop development, you might be using JavaFX. There's also 59 which are specific to the JDK itself, things like tools, things like the compiler, the ability to use those programmatically. And then there's 2 which are Oracle specific. The other big change that modularity brings to Java is not just breaking things up into more manageable modules, but also encapsulating the internal APIs. There are 4,500 public classes in RT.jar, but there's also a lot of other ones which are there to make the public APIs work. Now, right from the very beginning, Sun and then Oracle have always been very clear about this, which is you're not supposed to use the internal APIs. The reason they said that was because there was no guarantee that those APIs would continue to be available. There was no guarantee that they would continue to be used in the same way. So if you look at the internal APIs, you'll find there's no documentation for them in the public. There's no easy way of finding out how to use them. So the most famous or infamous of these is Sun-MISC unsafe. So let's have a show of hands. Anybody here used Sun-MISC unsafe? Okay, a few people. Okay, interesting. That side of the room a bit more heavily in using Sun-MISC unsafe. Okay, let me ask you another question then. Who here has used a third-party library or framework in their application? Now, come on, most people who use a third-party library, yes. Now, you probably have used Sun-MISC unsafe. You just don't know it because it's inside the framework or the library. So the idea here is that the developers of the OpenJDK wanted to encapsulate those so they would no longer be accessible. Problem is that lots of people, either directly or indirectly, have used Sun-MISC unsafe. And so rather than just cutting off access completely, they said, okay, we'll do it in a gradual way. We don't want to break everybody's code. So what we'll do is we'll introduce some command line options, which we'll talk about in a moment, that will allow you to continue using these. But ultimately, the idea is that these APIs will go away. They will no longer be accessible. Now, to solve the problem of people having used that, the idea is also to replace these APIs with ones which are public, which are documented, which have example code, and so on. The other thing that the developers of OpenJDK did at the same time was they decided to modularize the source code. This is the idea of saying, okay, we have all these different modules, let's separate the source code up so that the source code represents the structure of the module system, and therefore it's easy to see what's actually going on. Now, if we look at how to migrate applications from JDK 8 or earlier to JDK 9, then how do you do that? How do you just take your application and make it run on JDK 9? Well, the simple answer is just to leave it exactly the way it is. So you can, to all intents and purposes, ignore the module system. So you can say, okay, I'm going to leave everything I have on the class path. All my jar files are already on the class path. I have a command line which runs my application. That should just work. Again, we'll talk more about some of the compatibility issues in a moment. But when you're moving your application, you can initially ignore the module system. And you can say, right, just let it run, and we'll leave the application alone. The way that works is that anything that you put or leave on the class path becomes part of what's called the unnamed module. So unnamed module is a way of integrating existing code with the new module system without you having to do anything explicitly. anything that is part of the unnamed module system will depend on everything that's on the module path. So any of the modules which you specified for the runtime, any of the modules that you have for other applications on that module path, there will be a dependency there. So you don't have to make that explicit. The other thing is that all of the public elements of your jar files, of your classes, your packages, will be automatically exported. So they will be available to things on the module path as well. So it's a nice, simple way of allowing you to use the module system without changing anything. What you can then do is you can gradually migrate your application. You can take the jar files that you have at the moment, and first of all, you can move those from the class path to the module path. What that will do is it will turn that jar file into an automatic module. An automatic module, again, doesn't have to be changed in any way. What it does is it says, okay, the name of that module will be the same as the name of the jar file. It will export all of its public elements to the other modules on the module path, and it will depend on everything else in the module path. What you can then do is, if you want to fully integrate your code with the module system, is you can take your jar file, rebuild it with the module info.class file, which specifies specific dependencies, specific things that you want to make publicly available. So there's a nice gradual migration path from not using modules to using the module system completely. Now, I mentioned encapsulation of the internal APIs, and because so many people have used things like Sunmisk Unsafe, the developers of OpenJDK needed a way to allow you to gain access to those APIs, not to break your code. So they introduced this wonderfully named big kill switch. I think anything that has a command line option which is called the big kill switch, and the command line option itself is illegal access, is definitely an interesting thing to have. So what this allows you to do is to specify one of 4 values. So the default is permit. What this means is that by default, you will be able to access the internal APIs that you need without having to do anything. If you do so, the first time that you access one of these APIs, you'll get a warning message printed on the standard error output. If you're interested in getting more information so that you can track down where you're using these APIs and potentially change your code, then you can go to the next level. You can turn on warnings. What that will do is it will give you a warning every time you use a specific API. So rather than just giving you a warning the first time you use it, you get a warning every time you use it. Then, if you need more information, you can go up to the next level, which is debug. Debug will do the same thing. It will give you a warning message every time you use an API, but it will also give you a stack trace so that you can see exactly where your code was coming from when it actually used this API. And then the 4th option is deny. And that's the thing that will, at some point in the future, it's not clear when yet, but at some point in the future, deny will become the default, and that will turn off access to the internal APIs. Don't worry about that. It's not going to happen anytime soon. Now, the other thing you can do is, rather than just turning off encapsulation completely, you can be a little bit more specific about it. So you can say, okay, my code needs to use these specific internal APIs. But rather than just turning it off completely, I will specify exactly which of my packages need access to specific internal packages. And we can do that if we want to import code through add exports. And we can specify on the command line example here, we want to add exports from the Java management module, and we need the com.sun JMX remote internal package. We can then say that we only want that accessible by my test package. So it limits it to only my test package. If we want anything that's on the class path to be able to access a particular module's package, then again we can say add exports, java.management as the module, and sun.management all unnamed. So anything on the class path will then be able to import that package and use the public elements of it. If we want reflective access, because that's a way that a lot of people do tend to use some of these internal APIs, then there's another command line option that we can use. So we can do add opens, and then in the case of java.base module, we can say that the java.util package, we want all of that accessible for reflection to all the classes we have on the class path. We can also do the same sort of thing from a jar file itself. So rather than having to specify it on the command line, if we want to ship a jar file and not have to tell people when you use this jar file, you need to put these options on the command line, you can put it in the jar file manifest, and you can say add exports, java.base, Sun security provider, and that will do the same thing as the command line option. So there's a variety of ways of setting things up so that you can still use the internal APIs within the OpenJDK libraries. Now, the other thing you can do is you can actually look at your code. So if you want to start examining the jar files that you use and find out where you've used specific modules, so that if you've got modules you're using which you might not be aware of, then this could be useful so that you can track down things and make changes to your code if you need to. So there is this new command, relatively new, called JDEPs. JDEPs will analyze the dependencies that you have on different APIs. So I thought to myself, okay, let's run JDEPs on something that would be interesting to look at. And I thought, right, Minecraft. Minecraft is written in Java, so why don't we run JDEPs on the Minecraft jar file? So that's what I did. And if I list the dependencies, what I get is that we need a dependency on java.base. Well, that's pretty obvious because everything depends on java.base. There's java.datatransfer, java.desktop, java.management, java.naming. And then you get this interesting line which is not found. Now, I'm not quite sure, but I know what it means. Something wasn't found, but it's intriguing to me because I don't know what was not found. It doesn't tell me what was not found, just something was not found. So I think there's still a little bit of work that needs doing on the JDEP command, because that's not a very useful error message, not found. And then it tells me that there's the unnamed module 1.8.jar. The next thing that we need to consider with JDK 9 is a big change around how you can deliver the runtime for Java. Because we now have module system, and we have these 97 different modules, 28 of which are java.se, it makes sense to be able to select only the modules we need for a specific application. If you look at the types of applications that you're developing now, there's a lot of use of containers, so Docker and those types of technologies. Microservices. What we need to be able to do is to find a way of packaging just the Java runtime elements that we need so that we can put that into our container and we can ship that wherever we need to make it available. So Jlink is the answer to that. So what Jlink does is it says, okay, take a particular module that you have for your application, analyze the dependencies on that, and the compiler will do that. It will build the dependency graph that's required by the different modules, and then create a runtime that only contains those modules. When you run Jlink, you specify certain options, so you specify where the modules are coming from, you specify where you want the runtime to be built to, and what it will do is it will generate a directory structure which looks exactly like the JDK. So there's a modular runtime image, it has a bin directory which has Java in it, it has a conf directory, a jmods directory, a lib directory, and so on. And if we run the very simplest possible version of Jlink, where we say, okay, just add the java.base module, we get a runtime, and then if we run the Java command that's in the directory structure that was created, and we say list modules, what we will see is just java.base, very logically. If we run that on a slightly more realistic example, and we say, okay, I've got an application that I've written, it's in a module called com Azul app, and I want to output to my image again. If I run the Java command and list modules this time, what I will see is I've got java.base, I've got java.logging, java.sql, java.xml. Those are the JDK modules. And then I've got the modules associated with my application, app, Zoop, and Zeta. I don't have to specify all of those modules myself. That will be analyzed by Jlink, by the compiler, and as I say, the dependency graph will be created. The other thing that you might notice here is that there are some numbers added to these modules. So you've got java.base at 9, you've got commas.all app at 1.0. And you might be thinking to yourself, oh look, we've got versioning. No, don't get excited. The versioning there is only for information purposes. It doesn't actually work in the way that you expect versioning to work. So there is no ability to have different versions of modules and be able to resolve against those different versions depending on which one you actually want. Implications of Jlink. Now that we are building a runtime which only contains the modules that we need for our application, what does that mean? Well, if we go right back to the beginning of Java again, there's always been this slogan, write once, run anywhere, or as a lot of people refer to it, write once, test everywhere. And that's really been the key thing, because it means that you can take a Java application, and wherever you have the JVM and the JDK, you can run that application, because you know the right libraries are going to be there, you know that the right runtime, bytecodes will be interpreted, recompiled into the necessary native instructions. So it's cross-platform. Obviously, if we start using Jlink, then we're going to generate a runtime image which doesn't necessarily include all of the java.se modules. This then becomes a bit of an issue because, again, if you go back in the history of Java, there was a time when Microsoft got very interested in Java and they decided that they would improve on Java. So the way they improved on Java was to remove certain parts of the class libraries and add extra things to the class libraries. That very much upset Sun because it broke compatibility. You couldn't guarantee that running an application on the Sun JVM would be the same as running it on the Microsoft JVM. A lot of back and forth, a lot of legal wrangling, and eventually Microsoft agreed to settle. So how does this not break the idea of compatibility? Well, what they actually said is that even if you build a runtime image which doesn't include all of the Java SE modules, it's still conforming to the Java specification. The way that that works is that there are a couple of rules that your system has to obey. The first is that it must include the Java base module, because Java base is kind of like object in that everything relies on Java base. That has to be there. The other thing they said is that if you include any of the other Java core modules, OpenJDK modules, then all of the what are called transitive dependencies have to be satisfied as well. What that means is that if you look at something like the Java.sql module that we had in our example, that has transitive dependencies on Java.logging and Java.xml. So if you include the Java.sql module in your runtime image, then for it to be a conforming Java SE image, you must also have Java.logging and Java.xml. The Jlink tool will sort all of that out for you, so you don't have to worry about it, but it's just the kind of rules that apply in terms of having the being conforming to the standard itself. Right, let's talk a little bit more about compatibility, JDK 9 compatibility. This is a quote from one of the product managers at Oracle. I took this quote because I thought it was quite interesting. Clean applications that just depend on java.se should just work. It's kind of a little bit vague and not terribly encouraging in the sense of, well, I really want my application to work, but it should work. Okay, what does that mean? Right, so there is this thing about missing modules, because remember in that previous slide, clean applications only use java.se. Now, the product manager who said this is very specific in the language that he used, because java.se is one of the modules that's defined in the JDK for JDK 9. Java.se is what's called a meta module. Meta module is one that doesn't actually include any packages, it just includes references to other modules. And there are actually two meta modules. There's java.se, and then there's another one called java.se.ee. This is where things get a little bit confusing because there's the enterprise side of the standard edition of Java. In JDK 9, the java.se.ee module is not included by default. It's still there, it's still in the JDK runtime, but it's not included by default either for compilation or for the JVM runtime. That means that if you use certain packages which are part of the standard, then your code will no longer compile with JDK 9, it will no longer run with JDK 9 unless you make some changes. The things that are affected, there are 6 modules which are part of the java.se.ee meta module. There's Corba, there's transaction, activation, and then some of the XML processing which is related to the use of web services, specifically for SOAP-based web services. So here's a question. Anybody here still using Corba? There we go. Doesn't seem... Oh, hang on. I did see some... I saw a hand over there. Yes. Okay, that's one or two people over there that might have a little bit of an issue. Anybody using SOAP-based web services? Oh, okay, a few more people. Now, you see, this is interesting. You see, so SOAP-based web services might be a bit more of an issue. But Corba, probably not so much. Now, if you need to get round this problem, then, again, there are some ways of doing that. So the first is you can use the command line. And you can say, okay, I am still using Corba, in the case of the 2 people over there. And you can say, add modules, java.corba. Because the modules are still in the runtime, it's quite possible to use them. The other thing is that if you don't want to use the modules which are there by default, you can also, with the exception of Corba, use standalone versions which are available through Maven Central. There's specific reference implementations for each of the JSRs which define these different pieces. And then there's also a way of doing it through what's called the standalone, the upgrade module path. So you can do ---- upgrade module path and specify where these modules are going to come from. So again, this is the idea that in the future, things will change a little bit. It's to get you used to the idea that these things will at some point be going away. Right, so that was JDK 9. Let's now talk about how things are going to change as we move forward. First thing that is important is that there is this new idea of a release model for the JDK. What Oracle announced was that they wanted to move to a more agile way of developing the OpenJDK. Again, looking at the history of Java, it was 3.5 years between JDK 8 and JDK 9. It was about just under 3 years between JDK 7 and JDK 8. It was something like 4.5, nearly 5 years between JDK 6 and JDK 7. So we've had a very leisurely release cadence in the past. That means that people have had to wait a long time for changes. So Oracle wanted to get things moving more quickly. What they said was, okay, we're going to release a new version of Java every 6 months, starting from March of this year. So JDK 9 came out in September of last year. We're going to get a new JDK this month. On the 22nd, I think it is, of this month, there will be a new JDK, JDK 10. And then in 6 months' time, we'll have another JDK, JDK 11. As I said, the idea is to make the development process more agile, to be able to get new features to people more quickly. And the way that this is going to actually work is that rather than planning the features that were going to go into a particular release and then only releasing the JDK when those features were finished, it gets flipped around. And now it's the idea that, okay, we want to release a JDK in March, so anything which is ready goes into that JDK, and if it's not ready, it has to be delayed until September or the next March or whenever. So the idea is that only things that are ready get shipped in that particular JDK. If something isn't ready, it doesn't delay that JDK, it simply has to go into a later one. So this means that we now have new features more quickly. Obviously, the big features are still going to take a long time to develop, but we will be able to get access to things and changes in a much more timely manner. Another thing that Oracle announced was that they were going to open source more things. Specifically, what they wanted to do was to make the tools which people quite like, things like Flight Recorder and Mission Control, open source. So they were going to release that, they were going to put it into the OpenJDK project, and the goal of this was so that rather than having OpenJDK as the project, which is the source code, the reference implementation for Java SE, Oracle then build that and create a binary distribution of the Oracle JDK, which is slightly different to the OpenJDK because it has some extra bits in it. If you look at the OpenJDK and compare it to the Oracle JDK at the moment, there's other things like the browser plugin. There's things like WebStart. These are not part of OpenJDK, but they are part of the binary. So Oracle wanted to get to a point where there would be no difference at all, functionally, between a build of the OpenJDK source code and whatever Oracle delivered as their binary. This is targeted for the end of this year, so they're still working through the details of how to make these tools open source, but we should see that by the end of this year, that will all be part of the OpenJDK project. The next thing that they decided was that they needed a new version numbering scheme. And I did a bit of research on this because it was kind of interesting, and I wrote a blog entry about it, because it turns out that we've had almost as many version numbering schemes as there have been versions of the JDK. Literally every version of the JDK comes out with a new numbering scheme. And in JDK 9, they decided they were going to have a new numbering scheme. So this was now going to be JDK, major, minor, and security. So it's going to be 3 numbers separated by a period. The idea here was it's a much simpler numbering scheme to understand, both by people and by machines. So that was good. So we ended up with 9.0.1, 9.0.4 actually was the second release. So I'm still not totally convinced about the idea of the logic there, but 9.0.1, 9.0.4, I don't know. For me, 2 comes after 1, not 4. But anyway, so they looked at that and they thought, yeah, okay, so JDK 9 has this numbering scheme. Yeah, let's get rid of that. So we'll have a new numbering scheme because we're going to go to a 6-month release cycle. So I know we'll have a version numbering scheme which is based on dates. So rather than having JDK 10, let's have JDK 18.3 to indicate that it's year 2018 and it's the 3rd month, so it's March. This is very much like the Ubuntu way of doing things. If you've used Ubuntu Linux, then you're familiar with this idea. So it was going to be JDK 18.3, JDK 18.9, and so on. Okay, that didn't really go down very well. People didn't like that idea, and so everybody kind of said, no, we really don't want that. So the OpenJDK developers went, okay, we won't use that one. Let's have another version numbering scheme. So now we have the new numbering scheme. And this is now going to have 4 numbers. So it's going to be feature, interim, update, and patch. So feature is like the big number. So this is the same as the major number that was in the previous one. So we're going to have major number of 10, major number of 11. Okay, that's pretty logical. I like that. Then they introduced this thing called interim. Interim is a minor number, and it's always going to be 0. Well, if it's always going to be 0, why is it there? It doesn't make any sense, because, you know, if you're not going to change the number, why bother? But they say, oh, it's reserved for future use. So at some point in the future, they'll have a new version numbering scheme, which will use the interim number. Okay, then they're going to have update, which was the security number, and that has a slightly different rule about how to increment it, which thankfully means that it gets incremented by 1 each time. So you'll have 10.0.1, 10.0.2, rather than 10.0.4 after 10.0.1. And then if they need to issue a release between the scheduled updates, then they'll use the patch number, which will be an emergency number, so you get 10.0.1.1 or something like that. Hopefully, this will be the last numbering scheme that they come up with. I really hope so. Things that are going to be deprecated, or things that have been deprecated in JDK 9. This was quite a big change in terms of Java, because suddenly the developers of the OpenJDK decided that they actually needed to remove things. You know, Java is now 23 years old, and lots of stuff has been added. Nothing has ever really been removed. So they did a lot of tidying up in JDK 9. And they also said that this is going to continue in the future. Applets, as a deployment mechanism, have been deprecated. So again, show of hands, anybody using applets still? Okay, good. That's reassuring, because applets are going to go away. WebStart is going to go away as well. The CMS garbage collector, because G1 is available in the OpenJDK, the idea is that CMS doesn't need to be there. Got a low latency, or lowish latency I should say, garbage collector in the form of G1, so CMS has been deprecated. Some people are still not keen on the idea of losing CMS because it does give different performance characteristics, but we will see whether that disappears as well. A few other things, Java policy tool, JConsole, Doclet API, some smaller things have all been deprecated. And the big one is the java.se.ee meta module. So as I said, that has been left out of the like the standard build, so compiler and the runtime, which means that in the future, this is actually going to be removed completely from the JDK. Next thing to understand is availability of JDK updates. And this is really important, so we need to spend a few minutes talking about this. How you use Java at the moment how you're going to use it in the future is going to change. Because with a move to a 6-month release cycle, it means that there would be a lot of work for Oracle to do in terms of providing continued support for all of the different versions they come out with. So if you've got JDK 9, JDK 10, JDK 11 every 6 months, and if you want to try and provide support for that over a long time, it's an awful lot of builds and things to do. So what the Oracle have said is that they're going to use the same concept that have been used in things like Ubuntu, which is a long-term support model. So what they're going to do is they're going to say that every 3 years, they will nominate a version of the JDK as being an LTS version. And that will have support for a long time. Only, and this is very important, only for customers who buy commercial support from Oracle. So this is something that is a big change. There will be 3 years between long-term support releases. So that's 1 in every 6 JDK releases. JDK 8, in order to synchronize things, has been defined as a long-term support release. So simply because of the way that the release structure worked means that it is going to have updates for more than 3 years. But that's so that they can synchronize on this new LTS model. The next long-term support release is going to be in September of this year. So JDK 11 will be the next long-term support release. Okay, all good. Non-long-term support releases are called feature releases, and JDK 9 is a feature release. That's only going to have updates for 6 months. When JDK 10 comes out next month, there will be no more updates to JDK 9. Other really important thing of this change is there is going to be no overlap of support. Now, if you think about when JDK 8 came out, you still could get updates to JDK 7 for, I think it was nearly 2 years after JDK 8 came out. JDK 8 is still being supported even though JDK 9 has been released. JDK 8 will continue to be supported even after JDK 10 comes out, and in fact even after JDK 11 comes out. So there's quite a lot of overlap between releases up until now. In the future, after JDK 11, there will be no more overlap of updates for JDKs. Also related to this is the changes around Oracle binaries. So Oracle, currently, if you go to the Oracle website, you can go to java.oracle.com and you can download the JDK from there. These binaries are released under the Oracle Binary Code license. This is where you have to tick the box to say, I accept the terms and conditions of the license. No idea what those terms and conditions are, because like most people, I don't read them. One of the things that it does have is the classic field of use restriction, which means that you can only use the JDK in a general purpose computing environment. That means like a desktop, it means a server. If you wanted to use it in an embedded environment or even a kiosk, then you would actually have to license it from Oracle. So what Oracle have said is they're also going to move forward in terms of distributing binaries in a different way. They will now make binaries available, in fact you can download these already, under a GPL version 2 with class path exception license. This is a less restrictive license, so it means this is really good, because it means you can simply download it and you can use it wherever you want, you can distribute it in whatever way you want, all is good. They're also going to support less platforms, so this is a way of reducing the amount of work they have to do. There will be no more 32-bit binaries, so if you're using 32-bit Windows or 32-bit Linux, that's going to be a bit of an issue, because there's no more 32-bit binaries. There are no more ARM binaries from Oracle as of JDK 9. So if you want to use it in an embedded environment, that's not possible with the default binaries from Oracle. All Oracle wants to support is Windows, Linux, Mac, and Solaris Spark in 64-bit versions. And again, I've borrowed this slide from Oracle because this is actually quite important. What this shows is the availability of public updates for the JDK versus private updates. And if you look very carefully at this diagram, which might be a bit difficult, it's quite small font, but what I will explain to you is that what it shows is the orange bit is actually showing the non-public availability of updates. So the little bit at the bottom there says no public updates. And the important thing there is that as of 11.0.2, so that's 6 months after JDK 11 comes out, there will be no more public updates of JDK 11. You will have to switch to JDK 12. This is something that a lot of people haven't really understood when they've looked at what Oracle have announced, because Oracle talk about long-term support releases for 3 years. That doesn't mean you get 3 years of updates. You actually only get 6 months of updates. What this really means is that you will have to change your JDK every 6 months if you want to continue to get free security patches. That's a big change for Java. What's going to happen in the future? So, looking at the technical side of things, what are the features that are coming in new versions of Java? Well, JDK 10, that's coming out this month, so what's in there? Now, interestingly, the JSR for this is JSR 383. Being able to do this in 6 months is a real challenge, because the JSR and the JCP has always moved very slowly. It's been quite interesting to see how Brian Gertz, who's leading this particular JSR, has managed to make this work in 6 months. And the expert group for this is Oracle, it's IBM, it's Red Hat, SAP, and Azure. So I'm actually on the expert group for JDK 10. Everything is going ahead. The release candidate is actually out, so we can actually see that the work is going on, and everything is on schedule for later this month to get general availability. In terms of features that are going into JDK 10, with only 6 months, there's still actually quite a lot of things in there. I wrote a blog about this, and published it last week, and I found 109 new features in JDK 10. Now, okay, I'm stretching a point a bit when I talk about features, because there's a number of those are new APIs. But if you add up all the new things in JDK 10, I found 109 new things in JDK 10. Biggish things, certainly the most important from the point of view of developers, is the introduction of local variable type inference. So Java is finally getting the var keyword. Not getting val, just getting var. So now you don't actually have to specify the type of a variable. It can be inferred for you by the compiler within a local scope. So within a method, you can use local variable type inference. Example here is if you're creating a list, rather than having to say array list of type string list equals new array list of type string, then you can simply say var list equals new array list of type string. Saves you a bit of typing. And similarly, if you want to get a stream from that list, you can simply say var stream equals list.stream. And the compiler will figure out for you what the type of that variable actually is. Now, when you look at this, you think, oh, that's quite simple, isn't it? But it's actually, there's a lot of complexity in here, and there's a lot of discussion that's gone on about whether this is a good thing or a bad thing. And people get most upset because, you know, it forces list to be an array list of type string, and people go, well, I really want it to be a list rather than an array list of type string. You know, program to an interface, not to a concrete type. But this is only within a specific method, so you know you should be able to identify without too much problem what the type is, and because of polymorphism you can still treat the list as a list interface rather than as an array list concrete type. Other things that JDK 10 has in it. So the G1 collector now has a parallel full GC phase to it. This is to improve performance compared to the parallel collector, which used to be the default collector, now it's G1. So there's you know, better performance in terms of G1, although the G1 GC will still go back to a full compacting collection, which could introduce very long pauses for you. Application class data sharing, I'm not going to say a lot about that because there's actually a presentation on that. I think it's the next presentation. So Volker's going to be talking about that. Experimental Java-based JIT compiler. This is the idea of putting a new JIT compiler into the JVM so that you can do ahead-of-time compilation and things around that. Inclusion of root certificates. This is quite a big thing, and again, this is to bring the OpenJDK source code into line with what you get from the Oracle binary, and some smaller things around consolidating the JDK forests into a single repo. It's just really sort of housekeeping from the point of view of the build environment. A few other things. Heap allocation on alternative devices. So this is the ability to split your heap across RAM and non-volatile RAM. If you have that in your machine, then you can do that. The Java H tool that's been used for JNI, that's going away because now you can do the same thing through the Java C compiler tool. There is a garbage collector interface being introduced in JDK 10. That's not an interface that you can use from your program. It's actually purely in the JVM itself. So if you want to replace the garbage collector, should you choose to do so, with something else like Zulu do, then it makes it easier to integrate a new garbage collector into the JVM. So that's useful for us at Azul. Thread local handshakes. This is again a very low level thing in the JVM, which just improves the performance of certain situations around how you get to a safe point within the JVM and how you can pause individual threads rather than all at the same time. As I say, I counted all the things up that I could find, and I found there were 73 new APIs in JDK 10. I've kind of highlighted probably the most useful of those here. So the collections API, list, set, and map, there's now a copy of method for each of those, which will create an unmodifiable collection. There's also a new optional .or-else throw, which is really the same as the get method that you have at the moment, but is just a slightly different way of specifying that. And then, again, in terms of the streams API related to unmodifiable collections, is the ability to create a collector which will collect to an unmodifiable list, an unmodifiable map, or an unmodifiable set. A few miscellaneous things for JDK 10. There's a, yes, so the XML input factory.new factory method was deprecated in JDK 9. And then they realized they made a mistake. They shouldn't have deprecated it, so they've undeprecated it, or de-deprecated it, or precated it. But anyway, so the deprecation has been removed from that particular API. The ComSun security auth package, there's 6 deprecated classes that have been removed from there, so they've gone away completely. There's 1 deprecated field, 7 methods from the Java Lang security manager. These have all been removed as well. And quite important is that the JVM is now more Docker aware. This is quite important because in the past, if you ran the JVM inside a Docker container, then what you would end up with is potentially problems because the JVM would look at how much memory was in the whole machine, not in your container, how many CPUs were available to the whole machine, not your container, and so it would make it would set up various parameters based on that rather than what the container had. So that's been changed now in JDK 10. JDK 11 is already starting because, of course, that's only going to be 6 months away. So the same expert group that we had for JDK 10, the idea is to move to more of a sort of rolling JSR rather than individual ones. And at the moment, there's not much in JDK 11 because clearly, development work is only just starting. One is the idea of the Epsilon GC, Epsilon Garbage Collector. The Epsilon Garbage Collector is one that doesn't collect garbage. So it's like, wow, okay, so we're not going to collect garbage. How does that work? The idea is, well, clearly you don't want to allocate many objects. Really, this is designed as a testing tool. There are some people who think that it will actually be useful in production. I'm a little unconvinced about that at the moment, but the idea is to be able to test the effect of a particular garbage collector by turning off the garbage collector, measuring the performance, and then turning on the garbage collector and seeing how it changes. Dynamic class file constants, this is the idea of, at the moment we have invoke dynamic, which is the new bytecode introduced in Java SE7. That allows you to specify how to invoke a method defined at runtime rather than hard coding it into your bytecodes. Dynamic class file constants is the same concept taken to constants. I find this kind of weird because it's dynamic constants. So hang on, that's a changing constant. But it makes sense when you actually look at the JEP for this. So it's a way of improving how different languages can add new features to the way that the JVM works. So it's not just for Java, it's also for languages which are compiled on top of the JVM. The Java EE and Corba modules, they will be removed from JDK 11. So this is the idea that they're already sort of being removed, but now they're actually going to go away completely in JDK 11. And then local variable syntax for Lambda parameters. This is just extending the Lambda expression so that it can take advantage of the var keyword that's been introduced in JDK 10. Looking at the longer term JDK futures, obviously with very quick releases, small features are easy to identify, but what about the bigger things that are happening in terms of Java? Because bigger projects with bigger ideas. So there are a number of projects within the OpenJDK that are coming up with these ideas. First of those is Project Amber, and this is around simplifying the syntax of the Java language. One of the things that has been criticized in the past of Java is the fact that it's rather verbose. And we've seen a number of changes in earlier releases which have kind of tried to address some of that. Project Amber is a continuing idea of how can we simplify the language itself, less boilerplate code, less things that we have to actually type every time. Project Loom is about looking at how to improve the way that threading works in Java. This has always been something that we've been trying to improve, so there's some more work going on there in terms of continuations and what are called fibers. Project Metropolis is the idea of rewriting the Java virtual machine in Java, which kind of gets interesting. We'll talk about a little bit about that in a moment. Project Panama is a replacement for JNI. It's a foreign function interface, so that if you want to access native code directly from your Java, you can do it in a simpler way. And then Project Valhalla is about value types and specialized generics. Just to give a little bit more detail about some of these things, so Project Amber, one of the ideas here is about pattern matching. And rather than just sort of simple regular expression type of pattern matching, this is more to do with things like switch statements. And the example that they like to quote is where you might have a particular object, and what you want to do is you want to do something which is based on the type of that object. At the moment, what you would have to do is you'd have to have a complex if-else statement where you did if instance of integer, else instance of byte, else instance of long, and so on. With what Project Amber is proposing is that you will be able to do pattern matching in terms of the type for a switch statement and be able to say case integer, do this, case byte, do that, case long, double, and so on. So you can actually match on the type of the object, not just the value of the object. There's some other things that Project Amber is looking at, the idea of records and so on. Project Valhalla. So, as I said, this is around value types. Because if you look at Java at the moment, you have primitives, int, long, float, and so on, which were there originally to improve performance. We then got objects, so we got encapsulation, polymorphism, inheritance, and all those good things. But the two don't kind of match. So you end up with some problems because if you have a collection, you can't specify a collection of a primitive type. You can't have an array list of int. You have to have an array list of integer, and that has a lot of overhead because in order to put integer objects into the collection, you have to box the int, create an object for it. Then when you want to retrieve the value, you have to unbox it and get the value out. Lots of overhead in terms of garbage collection, object allocation, and so on. So the idea of Project Valhalla is to enable you to use a collection of type int without having to do the boxing and unboxing. It's also about the idea of value types. Value types are something that codes like a class but works like a primitive. So underneath you get better performance because you're not having to treat it as an object. It's more treating it somewhat like a struct that you might have in C or C++. So you treat it like a class in terms of coding, so it has methods, it has fields, you can implement interfaces, you can use encapsulation, you can use generics, all those things. But from a performance point of view, it works like a primitive, and so you don't have the overhead of an object. Project Loom, as I said, is to simplify concurrency in terms of Java further. So we've obviously had things like the fork join framework, we've had the concurrency utilities. Now it's about how to take that the next step, because threads, if you want millions of threads, are too heavyweight in terms of how they interact with the operating system. What Project Loom is going to do is introduce the idea of fibers. Fibers are threads at the JVM level. So for those of you who have enough history, you can remember things like green threads as they were in Java a long, long time ago. So what this really does is adds the concept of continuations to the JVM. It's going to build on the work of the fork join pool scheduler, so a lot of the work is already there. And it's the idea that by having these very, very lightweight fibers, the context switch overhead is effectively zero. So you can switch between these fibers very, very quickly. You don't have the overhead associated with the operating system underneath. Project Metropolis, as I said, rewrite the Java virtual machine in Java, which sort of gets a bit confusing because if you rewrite the Java virtual machine in Java, don't you need a Java virtual machine to run the Java virtual machine? But then the Java virtual machine is written in Java, you need another one underneath that, and you end up with a very complicated environment and a recursion. No. So what this does is it says, okay, just because you write the Java virtual machine in Java doesn't mean you have to compile it into bytecodes. So this is the idea of using ahead-of-time compilation. You compile the Java into native instructions for a particular platform, and then you run it as native code. But the reason we don't do that already is because it gives you worse performance. You can optimize code more efficiently using a JIT. So the idea is that the JVM will start running using AOT code, and then it will be recompiled, or sections of it will be recompiled using the JIT compiler in order to improve performance. This is built on the work of the Graal compiler project that's been around for a while now, and so has some interesting ideas. That's certainly something that's quite a long way off in the future. It's not going to happen anytime soon. Just one thing I would like to mention is Azul's Zulu Java, because I work for Azul, so I might as well mention this. What this is we create a binary of the OpenJDK. So we take OpenJDK, we build it, and then we run all of the TCK tests on it. We make sure that it's fully conforming to the specification, and then we make it freely available. So you can go to our website, zulu.org/download, and you can download it for free. We support older versions, so we have JDK 6, 7, 8, and 9. We will continue to support newer versions as they become available, and we also have wider platform support. So we actually have Intel 32-bit Windows and Linux. We have ARM 32 and 64-bit. If you're interested in specific support for that, then obviously we're quite happy to talk to you about that. Just to summarize then, Java continues to move forward. There's lots of interesting things happening in the space of Java. So JDK 9 is out. We have the modularity system finally in the JDK. Remember, JDK 9 is not a long-term support release, which means that as of this month, no more public updates for JDK 9. Faster Java releases, one every 6 months. This is something that's going to take a bit of getting used to. It's also something that we need to adjust to in terms of figuring out how to deploy, how to get the security patches, how you'll make that available in terms of your deployments. Lots of ideas in terms of improving Java further. So it's not a language, it's not a platform that's standing still. There's things like value types, there's things like Project Loom, fibers, and so on, and many, many smaller things as well. So with that, thank you very much.